Okay, we are welcome to another episode of Math Phobia. Alright, I want to start a series. We just concluded a series of quadratic equations by factorization. So, we want to start a new series on circle geometry. I know many students don't like this topic. When you ask them, sure, list of topics you don't like, the first, mostly SS2, SS3 students, they will tell you circle geometry. Alright, now follow me. Let's solve this question easily, step by step. Don't forget, our aim of this class is to rekindle the love for maths. Now, we have this question, alright? And we are giving some conditions. Now, if you want to solve questions accurately in circle geometry, you have to follow conditions. You have to listen. Take note of the conditions given to you because there are times when you solve questions like this, you'll be stuck. You don't know the next thing to do. You've tried everything possible. Your conditions are what you still fall back on to get the job done. Now, we're told that OBCD, we have a circle of center O, okay? We're told that OBCD is a rhombus. Take note of that, a rhombus. Now, a rhombus. Okay? Take note, a rhombus. Now, we are told that ADO and ADO, which is y, is equal to OBA, which is y. So that's correct, they are equal, alright? So, then we're also told that OBCD is a rhombus, okay? Then find T and find Y. First of all, there are two ways to go about this question. First, you can start by the theorems you know about circle geometry, alright? Or you start by the conditions given to us. Now, let's start by the theorems, alright? So we have some theorems in circle geometry and I'll apply some of them to solve this question. Now, follow me. First of all, what we can see here, let's analyze this circle. We'll see that we have a cyclic quadrilateral inside the cycle, right? Inscribed in this circle, rather. What is a cyclic quadrilateral? A quadrilateral is simply a four-sided figure, all right? It can be square, trapezium, rhombus, a four-sided figure. But what is a cyclic quadrilateral? We are saying a four-sided figure such that its edges touch the circumference of the circle. So we have an edge at A, are we there? We have an edge at B, we have an edge at C, and we also have at D, and finally we have an edge at C. So the four edges of the quadrilateral touches the part of the circle or the circumference of the circle. So as long as those four edges touch any part of the circle, it becomes a cyclic quadrilateral. And what's the first condition for a cyclic quadrilateral? If here is T, opposite angles of a cyclic quadrilateral are supplementary. So what do I mean by that? So if here is T, it means here is going to be 180 minus T. Opposite angles of a cyclic quadrilateral sum up to 180. So that means the angle here plus the angle here should give me 180. The angle on B plus the angle on D should give me 180. That means the sum total of the angles in the cyclic quadrilateral is what? 360 degrees. When this plus this gives 180, this plus this gives 180. Overall total, 360 degrees. Now follow me. So if here is T, to get this side, 180 minus T. Now, another thing you need to check for is this. So that's the first thing you check for. Check, we have a radius, two radii. A radius is a line drawn from the center of the circle to any point of the circumference. So we have two radii, meaning if this line OB, if OB is the same as OD, what does that imply? It implies that this angle here, let's call it X, will also be equal to this angle here. So we have XX. Is it making sense? It's making sense, alright? And this means this forms an isosceles triangle. Follow me step by step. So this is the first condition. I observed and I saw a cyclic quadrilateral in this question. So I applied the theorem to get this side 180 minus this because this side plus this side will give you 180. Okay? Then I also looked, I saw two radii, meaning if I have two radii, the two angles at each side should also be equal. Now, another thing I can see from this guy is that I can see the very first theorem applied in circle geometry. So that is why, instead of cramming the theorems, use them in questions. The best way to gain mastery of something is to use it in solving questions. I also observe that this theorem will work. The angle formed at the center. Okay, this implies if OB equals to OD, it implies that angle OBD is equal to angle ODB. Okay, and that is what? X. Now, we have that from here. We have the angle formed at the center of a circle is 2 times the angle formed on any part of the circumference. So that theorem also holds. So that means the angle formed at the center is 2 times this. You are going to have what here? 2t. I see the way I'm applying these things step by step. Now, is there any theorem for me to use? Okay. I think I'm done with the theorem for circle geometry. Alright? As far as I'm concerned. Now, follow me. What's the next thing we have to do here? This is we have 2 triangles. 3 rather, there's still 1 under, but we don't need this 1 under. Let's work on these 2. So from triangle OBD, we have that what? Sum of angles in the triangle 2t plus x should give us 1/8 sum of angles in the triangle. So this should give us 2t plus 2x to be what? 180 degrees. Let's keep that one. Equation 1. Also, let's use the bigger triangle. From triangle ABD, the bigger one. Sum of angles in the triangle, we have t plus these 2 they are together. So we call them y plus x. Y plus x, we come to this side again, plus y plus x, total 180 degrees. Why? Same reason. Sum of angles in the triangle. So what do we have? Collect items. We have t, x plus x, we have 2x, y plus y, we have 2y, equals to what? 180 degrees. Okay, now, if I bring down my equation 1, let's call this equation 2. If I bring down my equation 1 here, I'm going to have 2x, 2t, sorry. I'm going to have 2t plus 2x. I don't have anything pertaining to y, so let's just call 0y. I don't have anything there, nothing. Equal to 180 degrees. Equation 1. So let's solve this simultaneously. By this elimination method, 2x minus 2x gone. So what do I have left? T minus 2t. That will be minus t, 2y minus 0 plus 0y. So this is minus 2y minus plus 0y. 2y minus y minus 0. Rather, we have 2y. Okay? 180 minus 180, we have 0. If I take minus t to this other side, I'm going to have 2y equals to t. Very important. So we have t is what? 2y. Follow me step by step, step by step. Now, we've got to this point. What is the next thing to do? And this is the part I talked about earlier on, that some students get to this part where they get stopped and they don't know what to do. The only remedy you have to this situation is go back to the conditions you were given in the question. Now, what is the condition? We were told that this is a rhombus. Now, isn't that striking enough? Giving us a rhombus. And we know that in a rhombus, one of the properties of a rhombus is that opposite sides of a rhombus are equal. Opposite sides of a rhombus are equal. So what does that tell you? Look at what I have here. I have this side and I have this side. Have you seen how the conditions are bailing us out? Alright, so what do we have from here? That means I'm going to have, since opposite sides of the rhombus are equal, I'm going to have 2t equals 180 minus t. Bring this t to this side, I'm going to have 2t plus t equals to 180. So what do we have? 2t plus t, 3t equals to 180. Meaning we are going to have t equals to 180 over 3. When you divide both sides by 3. And our t is what? 60 degrees. So that we have t to be equals to 60 degrees. And we have gotten our t. We have been rescued, right, from this situation. Now, we've gotten t. How do we find y? We'll come back to this equation of God. Let's call it equation 3. And we know, don't forget, we know that t equals to 2y. So let's come to this side. We know that t is equals to what? 2y. So I want to find y now, right? So meaning we divide both sides by 2. So that means y is t over 2. And we solve for t. What did we get for t? We got 60 degrees for t. So we have 60 over 2. And y is what? 30 degrees. So we've gotten our t and we've gotten our y. Step by step approach. Alright, in solving this problem. Alright? Please like and share this video and also follow me for more videos. We are dealing with circle geometry. That thing that scares students in circle geometry, we want to deal with it seriously, alright? And mathematically. So subsequent videos will look at other areas of circle geometry and how they can be solved using these two methods I've mentioned. Analyzing the question you are getting at, that's step 1. The question you are given, analyze it. Then step 2, check which of the circle theorems apply to the question. And then step 3, go back to your conditions given in the question. Thank you very much.